Hello friends, welcome back to this online lecture series on earthquake resistant design of structures. Now in the lectures up till now we have been discussing regarding the importance of ductility and its effects on the performance of effects on the performance of masonry buildings as well as the reinforced concrete building. In today's lecture we are going to discuss one new feature, that is one building or one type of feature that is there in the building, as a result of which the performance of this building is likely to be affected when subjected to lateral load or the ground shaking, right? And that is what today I am going to talk about, is the performance of open storage buildings or open ground storage building, right, when these buildings will be subjected to lateral loads. So let us start today's discussion. Right now, when I am talking about the ground storage building, first we need to, as we have done in all the previous lectures, first we need to understand what these buildings are and how these buildings performs under the effect of lateral load. So that is what we are going to discuss first, right? So why are open ground storage buildings vulnerable in earthquake? That is a reasonable question that we can ask, right? Because we have discussed different buildings, that is two basic types of buildings, that is masonry building and reinforced concrete building. Now in case of reinforced concrete building, again we are going to discuss couple of problems that we see in day-to-day life, as a result of which the performance of the building is deteriorated under the effect of lateral load. And that is why this question is valid, that why the open ground storage buildings are vulnerable in case of earthquake. So now, as you know, that in the present scenario, the modern urbanization is asking for the demands of construction to be increasing on day-to-day basis. That is, the number of high-rises and number of skyscrapers in the city are increasing day-to-day, right? And the present scenario is such that recently the Gujarat government has announced that they are going to allow the construction of 70-story buildings, right? So these buildings or the construction of these buildings or the skyscrapers does not harm as a structure engineer, but very few important aspects are to be there which need to be kept in mind while designing these structures. If these aspects are kept in mind, then as a result of that, we can rest assured about the performance of the building irrespective of the height of the building, right? So that is why this feature is there, that is the open ground story building. So the trend is such that you will see a lot of high rise and skyscraper building in the city and in the country coming up. But there is one very peculiar feature that each and every one of you can associate with the high rise buildings or the apartment buildings, that is the presence of parking at the ground level, right? Because if you look at the present trend of construction, then we have that the buildings are going to have one basement or two basements. After that, there is the parking story, which is known as the ground floor level, and from the first floor onwards, the residential or the commercial units will be there. And this is the feature that you will see in all kinds of buildings, whether it is commercial building, whether it is residential building, whether it is institutional building, because the accommodation of parking with the increase in the population is becoming a major problem for all of us. So the proper allotment of parking is also one of the key components for the good performance or good planning from the developer's point of view. But at the same time, the structure point of view also needs to be considered, and that is what is happening right now. That from planning point of view and from utility point of view or the functional point of view, all the requirements are met, right? That is, we check the number of two-wheelers that are going to be possible, number of four-wheelers that are going to be possible, where is the parking zone, where the parking will be done. All these criteria are cross-checked once you are going to put the project on the site. But from structure point of view, one negligence or one ignorance is there, and that is, we do not speak up about the harmful effect of ground story buildings when it comes to structure engineering, right? And that is what we are going to understand, that how these open story ground buildings, which are an important feature for accommodation of parking, can become a harmful source for the structure engineer and the life of the building as well, right? So that is what we are going to see in today's lecture. Now, what happens in case of ground story buildings is that the columns are going to be there at the ground level, but between these columns, the partition walls or the masonry walls are not provided, and that is why these buildings are known as open story buildings, or also known as the buildings with the stilts, right? Now, somebody may argue that, okay, if you are seeing building where the only columns are provided at the ground level or shear walls are only provided at the ground level and the masonry infill walls are not present, then what is harm in that? There is no harm in that, because from parking point of view or for movement, from considering from the movement of vehicles, then it is a necessary thing that sufficient space should be available for the movement of the vehicles, right? But when you are ensuring all these things from function point of view, from movement point of view, from accommodation of vehicles point of view, from bylaws point of view, everything you are considering, but then you also need to take into consideration the strength of the building, whether you are going to play with the strength of the building or not. That is the question that one needs to ask, right? And I hope that today's lecture is going to give you a sufficient insight about the importance of masonry walls at the ground level itself, so that the strength and the ductility of the building can be ensured. Right. So when I talk about the open story buildings, then the history itself is saying that the performance of these open stories buildings have always remained poor in case of earthquake. That is, if I talk about the 1999 Turkey earthquake or the 1999 Taiwan earthquake or 2003 Algeria earthquake, in all of these cases, it has been observed that the buildings with ground story have been vulnerable to earthquake, and as a result of that, lot of buildings of similar geometry or similar type of planning have collapsed during the severe shaking of the ground. Right. So when I talk now, this is a scenario that is observed worldwide. But when you come to India, or when you talk about at the local level, then again we can say that a large number of buildings are coming day to day. A large number of buildings can be seen coming up in the country or as well as in the city also. So if I talk about Ahmedabad itself, then in case of Ahmedabad, it is there said that approximately 25,000 five-story buildings are present, and around 1,500 11-story buildings. Now this is the data that is old data. But if you look at the present situation, then all the buildings are either 7-story buildings or 12-story buildings, 14-story buildings, and now we even have the 22-story buildings. And next we are going to have the 30-story buildings and the 70-story buildings that are coming up, right? So what is going to happen is that large number of these buildings are coming up on a daily basis, but at the same time all these buildings are going to have the same feature, that is the open story is going to be there at the ground level. Why? Because parking facility is to be provided, and when this is done, then that is the absence of partitions wall is going to be there in this type of buildings. Now these buildings are located, I have given the example of Ahmedabad only, but similar types of buildings are coming up in other cities also. That is the buildings located in zone 3, zone 4 and zone 5. All these three zones are going to be seismic prone zones, and any building that is going to be a multi-story building with open story at the ground level is going to be severely affected if properly not detailed or properly not designed. Right. So now what is the actual problem? That is what we are going to understand next. That is that from function point of view it is okay, from elevation point of view it is also okay, but from structure point of view, what is the actual problem as a result of which we are taking up this topic under the effect of earthquake loads today? That is, the buildings which are going to have columns at the ground floor and columns and masonry walls both at the stories above are going to have two peculiar features. Where the first feature is the presence of, or you can say that the buildings are going to be, the ground story is going to be flexible in nature. Why it is going to be flexible in nature? Because the amount of horizontal displacement that the ground story is going to undergo is going to be larger as compared to the stories above. Why? Because the stiffness at the ground level is going to be less as compared to the stories of the as compared to the stiffness of the stories above. Because in case of the stories from the first floor to the above stories, or the terrace level, we can say that the contribution of infill walls in the columns both are going to be combined effect, and as a result of that the stiffness above is going to increase. Whereas in case of ground story, only the columns are going to be present, and when only columns are going to be present, then as a result of that the stiffness is going to be less as compared to that of the columns above. And as a result of that, it can say that the horizontal displacement is going to be larger at the ground level as compared to the horizontal displacement of the stories above. And if this situation is there, then IS 1893 is coining this particular term or this particular behavior in the structure as a soft story. Right? That is what we have discussed earlier also, that soft story is one of the reasons as a result of which the open story buildings cannot perform sufficiently in case of earthquake loads. And the second condition is known as the weak story. That is, you can say that the total horizontal force that it can carry at the ground floor is going to be much lesser or much smaller as compared to the stories that can take above. Why? Because the stiffness is going to be less. If the stiffness is less, then the load carrying capacity is also going to be less, and the load carrying capacity is going to be less, then as a result of that, what is going to happen is that this particular type of story is going to have lesser resistance to the earthquake forces, and as a result of this, the second term that is being coined in IS 1893 is weak story. That is, this story is going to be comparatively a weaker story as compared to the stories above. That is, the ground floor is going to be the weaker story, and the above stories are going to be stronger in comparison to that of the ground floor. Right? Now, what is going to happen is that when the geometry is going to be such that there are only columns at the ground floor. Then from the first floor onward, the columns are also going to be there and the walls are also going to be there. So as a result of that, what is going to happen is that the above stories are going to act as a single unit or a single block, and they are going to move together under the application of lateral loads. Whereas in case of ground floor, only the columns are present, and as a result of that, the movement is going to be that like of an inverted pendulum, which we will see in the figure that I am going to show in the next slide. Right? So as a result of this, when these horizontal forces will be acting on the building, then as a result of that, the building is going to undergo the horizontal displacement, and since reversal of stresses we have discussed that in case of lateral forces, reversal of stresses is going to be considered. That is, the earthquake force is likely to act in one direction, that is plus direction, and the minus direction as well. So as a result of that, the back and forth movement is going to be there. When the back and forth movement is going to be there, then it is going to severely affect the strength of the columns at the ground floor, and at the same time it is going to affect the ductility of the columns as well. So the columns are going to be severely stressed from ductility point of view also, and from strength point of view also, when this type of geometry is seen in the building. So as you can see in the figure over here, where first the figure of a inverted pendulum is shown, where a single circular bar is shown, on top of that the mass is shown. Now if I am going to apply the horizontal force on this pendulum, then what is going to happen is that the stiffness of the bar is going to be different, stiffness of the ball is going to be different. So as a result of that, the heavier mass is concentrated at the top, so stiffness is going to be more at top, less at bottom. As a result of that, the behavior is going to be the one as you can see in the figure over here. Same thing if you apply in case of open story buildings also, then you can say that the stiffness at the ground floor is going to be less, the mass is going to be more at the upper stories. So as a result of that, the stiffness is also going to be more at the upper stories, and since the stiffness at the upper stories is going to be more as compared to the stiffness at the lower stories, so as a result of that, the behavior is going to be similar to that of an inverted pendulum, as you can see, right? So the upper portion of the block that you can see is going to act together as a single unit, and the lower portion of the building, that is the ground story columns, are going to be on the weaker side, and their flexibility is going to be larger as compared to the portion that is going to be above the ground story. Right? Now when this particular thing is going to happen, then the type of behavior or the type of demand that is required from the column is that it should be capable of resisting large amount of lateral forces. That is, the shear capacity of the column should be on the higher side. And second thing is, good amount of ductility is also required. Why? Because as we have seen that the ground story is going to be flexible in nature, and when it is going to be flexible in nature, then it is going to undergo the back and forth movement. And when back and forth movement will be there, then as a result of that, large lateral deformation will take place in the either direction. So if sufficient amount of ductility is not there, then as a result of that, it will not be able to withhold its position, and the collapse of the structure is likely to be initiated. So in the previous discussion that whatever we have had regarding the performance of masonry buildings and the RCC buildings, we have seen that the design of column was critical in case of shear only, right? That is, the shear capacity of the column should be increased. But in case of open story buildings, the criteria is changing. That is, the columns need to be ductile in nature also, and at the same time they should have good shear strength also. That is, the ductile capacity of the column should be also there, and at the same time the shear resistance of the column should be on the higher side to resist large amount of such change in the stiffness. So here you can see the examples of performance of two buildings under the two different types of earthquake that have taken. First example is the figure of a building that has collapsed in the 1971 San Francisco earthquake, and second is the G+3 structure that collapsed during the 2001 Bhuj earthquake. In both these cases, the open ground story was present at the ground level where the parking facility was provided, and as a result of that, there was flexibility that was generated in the ground story, and as a result of that, the performance of this building could not perform well under the effect of lateral loads, and as a result of that, the failure of the structure took place. Right now, where actually the problem is? One problem is, we have already seen that the provision or the insufficient provision of masonry walls is one of the problems. That if sufficient amount of masonry walls or the infill walls are not provided at ground level, then it is going to create a problem. Now the second problem is at the office level or the design office level. Why? Because as you can see in the figure, the actual building is the one where the masonry buildings, the frame structure is going to be there, where the major load transfer is going to take place from the beams to columns and from the columns to the foundation and to the soil below. And between these columns, the masonry infill walls are going to be there, right? So in majority of the buildings, you will see that the masonry infill walls are going to go, right? This element is such that which is going to be present irrespective of the functionality of the building, whether it is a residential building, commercial building, institutional building, whatever type of building. The walls are always going to be present from the functional point of view and from privacy point of view also, right? So as a result of that, these walls are never going to be eliminated from the structure. But what happens is that when this particular structure is being modeled in the design office, then in that case, the effect of masonry infill wall is not considered. That is, the structure that is going to be modeled as a bare frame structure. When you are going to model this particular structure as a bare frame structure, then as a result of that, the effect of inverted pendulum that we have seen in the earlier slide cannot be visualized in the design office. And as a result of that, whatever assumptions we are making in the design office are not falling in line with the actual performance or the actual condition, actual condition that is going to be there on this side. So this is also one of the additional problem which needs to be addressed by the structure engineer in the design office as well. Lastly, the question comes is, what is the solution to this problem? That is, we cannot close the ground story structures from all these sides by introducing the masonry walls and completely eliminate the parking. That is also not one possibility, right? Because if that is how we are going to deal with it, then how the movement of vehicles will take place, or how the movement of the persons that are going to live in the building is going to take place. So complete elimination or complete closure of the boundary, peripheral boundary, is also not an solution that we can say that it is going to be an optimum solution for ground story. But what can we do is that if you are going to put a new project on site, then from the planning stage itself only, this particular aspect should be taken into consideration. The mutual meeting should be held mutual discussion should be held between the architect, the structure engineer and the developer. And the structure engineer needs to brief the architect as well as the developer regarding the consequences that are going to happen if this building is going to be designed with an open ground story, right? So once the client is also going to be educated, then as a result of that, I'm pretty sure that some viable solution will be worked out by the developer and the architect as well, and some modification will be done in the planning. So if you are going to put up a new project, then in that case, the first suggestion is that the discontinuity in the wall should be avoided, and the open ground story structure, or the soft story or weak story, should be totally eliminated from the building. Now, how this can be totally eliminated? That is, you do your calculation for the parking and allotment of the parking of vehicles for the parking, and you put sufficient amount of provision in the basement itself. That is, you plan your project in such a manner that the basement itself is capable of residing all the vehicles that are likely to be there in this particular campus, right? So that is how proper planning will help us to eliminate this problem to some extent. Second is, somehow the space constraint is there, and as a result of that, all the vehicles are not accommodated in the basement, and somehow it is compulsory to accommodate the vehicles at parking level also. Then what can be done is that rather than 100% elimination, or rather than 100% discontinuity between the wall, effort should be made that at least the continuity of at least around 70 to 60% of the walls is maintained. Now, when I am talking about the continuity, I am not talking about the continuity along the length, I am talking about the continuity along the height of the wall. That is, the continuity should be there between the height of the wall. That is, if at a particular location, the wall is present at the ground level, then at the same location, the wall should be present in the above stories as well. Why? That you will see in the next slide that I will show you. Right? So, if this type of planning is done, where the proper functional requirement is also understood and the structure aspect is also understood, then definitely we will have a better product on the side, right? So if 100% elimination is not possible, then at least effort should be made that at least 50 to 60% of continuity of wall is maintained at the ground level. And lastly, next the thing that comes is regarding what should be the solution for existing buildings, because for new buildings we have already discussed that these two solutions can be preferred. But what about existing building? Then in case of existing buildings, the codal provisions are saying that if your building is going to be having a soft story effect or weak story effect, then it should be designed for so and so type of forces. This clause is given in IS 1893. So whichever buildings have been designed for this particular type of forces, that is the weak story or the soft story effect is observed in these buildings, then they should be cross-checked again as per the guidelines of IS 1893, and if required, that if required and found that these columns are deficient in carrying the lateral forces as mentioned by IS 1893, then the shear capacity of these columns should be enhanced by adopting any of the retrofitting techniques that are possible and that are available in the market. Now, in order to get an idea about the retrofitting tactics, a qualified structure engineer should be hired, and he should be assigned the task of reviewing the entire design of the building, and he should take into consideration all the clauses related to soft story and weak story that are mentioned by IS 1893. That is, approximately 5 times shear should be applied on the soft story, and the performance of the building should be checked. Right? And once this is done, then the appropriate retrofitting technique should be adopted, and these buildings should be enhanced before a major collapse or major calamity is observed under the effect of lateral loads when subjected to the earthquake forces. And lastly, the importance of having the continuity in the masonry walls that I was talking, that is the continuity along the height of the wall, right? So what is going to happen is that, as you can see, that the lateral force is going to transfer from top of the building to the bottom of the building, that is to the foundation, and from the foundation to the soil, right? So it is going to be important that the continuity of wall is there. If the continuity of wall is there, then the even distribution of forces will take place along the height of the building, and symmetric load distribution will take place, and as a result of that, the load part will be sufficient enough where the horizontal forces can travel from the beam column joint and from one joint to the other joint, and vertically they can travel downwards and reach the ground level, and from the ground level they can reach to the foundation and then to the soil below. However, as you can see in this figure, if for any story, if the masonry infill wall is removed, then what is going to happen is that there is going to be change in the stiffness, and at the same time the load path is also likely to be diverted. And as a result of that, what is going to happen is that uneven distribution is likely to take place, and as a result of that, some kind of stress is likely to be developed in the building as well. Right? So that is why the consideration of infill walls in the design office as well, at the planning level also, and execution level also, is going to play an important role in the performance of open story buildings when subjected to lateral loads. I hope you have understood the importance of provision of masonry walls in these open story buildings in order to enhance its performance under the effect of lateral load. Stay tuned for the further lecture series. Thank you.